8.1c in the AP workbook. A toy company claims to have developed two toy car models, which they call A and B, where the average speed of each car is identical. So this is the speed, right? 0.5 meters per second, plus or minus 0.02. Now, let's talk for a second about what this means. This is the uncertainty. This is the limit of the measuring tools, okay? So that means it could be as high as 0.52 and as low as 0.48. Okay. Each group of students is given the two toy cars, one of each model, meter sticks, stopwatches, and is asked to test the toy company's claim. The students decide that they need to collect distance and time data for each car to test the company's claim. The students design a procedure. Cross out any extraneous steps and order the remaining procedural steps. So we have to turn the car on and release along the measured path. Gather equipment. Well, that's understood. You don't need to say that. Okay, we never talk about that. You have it, you have it. Okay, repeat to reduce error. That's going to be important. Measure and record the time the car took to travel the 2 meters with a stopwatch. That's kind of important. Measure a 2-meter long path along the floor and draw a data table in your notebook. You don't need to say that. That's understood. That's not part of the experimental procedure, okay? So we've got 4 steps. What has to happen first? Well, first thing we have to do is we have to measure the 2-meter long path. We have to turn the car and release it. Then we have to measure the time and record it. And then we have to repeat it a few times to reduce the error. Okay, so that's the order. Again, I want to emphasize that gathering equipment and drawing the data table are things you're going to need to do, but it's not part of the procedure, so it does not get written in. Part B. Given is a data set collected by students in the class. Based on the data, what conclusions should the students make about the hypothesis that the two cars A and B have the same speed? So you might just look down at the average and say, oh, look, they're exactly the same. But never do that. Always make sure you look at the actual data. So here's the different lab groups, and here's car A, here's car B. So let's say 0.45, 0.46, 0.42, 0.43, 0.74. This to me really stands out. And then if I look at this one, I go 0.54, 0.52, 0.56, 0.55, 0.23, and 0.54. There's something going on with group 5's data. Now I'm going to tell you, this happens all the time. Whenever we do class data collection, there's always at least one group that makes a mistake. Not the end of the world, and it's often really easy to pick, but you have to actually look through the information to see what's going on. Once you say, okay, I'm going to take out these 2 outliers and recalculate the, let's see, where's my calculator? So I'm going to recalculate the averages, okay? So I'm going to do 0.49 times 6, because I had 6 data points. I'm going to subtract that 0.74 and then divide it by 5 instead. This is 0.44. And I'm going to do the same thing here. Now, if you just want to add them in, that's fine. This is my little shortcut trick. This one is 0.542. So they have different average speeds, right? You can see that clearly, and it's significant because you're talking about a difference of 0.1, which is about, anywhere, depending on what you use as your given value, right? You're talking about 5% or 10% difference between the two. So once the outlier group 5 is removed, the averages are significantly different. Okay, so you just write that out. The students decide that additionally they want to test the toy company's claim that the car's speed is constant throughout the motion. How, if at all, does the experimental procedure from Part A need to be modified to verify that the car's instantaneous speed is constant? Now, this requires that you know the difference between average and instantaneous speed. So in this procedure, right, they took the 2-meter distance. So this was 0, 1, 2 meters. They released the car here, and they said the time initially is 0, and the position was initially 0, and then they measured the time here. Right, this is where they took a measurement, and this was given already. I mean, this is 2 meters. And so the speed they got in here would be V equals D over T, which would be 2 meters over whatever that time is, right? Whatever that measured time value. And that's how they got these values. Okay. But that's average speed. Instantaneous is, what is it here? What is it here? What is it here? Like at different points along the trip. And so you have to reduce this delta D, sorry. You have to reduce that delta D in order to figure out what that speed is at that position. So this is something that people have trouble with, and it comes up in lots of different units. So it's really important that we work on this part. So Angela thinks they should use a motion sensor to collect speed versus time data. If the graph of speed versus time is horizontal with 0 slope, the instantaneous speed is constant. Blake thinks they should use photo gates positioned at the beginning and end of the 2-meter long track to determine the instantaneous speed of the cart. The students measure the length of the cart and divide this length by the time recorded by the photo gate to determine the instantaneous speed. So we haven't learned. We may have played with these. I'm not sure if we'll have done this by the time you do this activity. So let's briefly talk about what these things do. A motion sensor would be placed probably over here, right? It's a little box, and it'll record, it sends out ultrasonic, and it records the position and time data and generates a graph of position versus time for the entire trip. Now, if you set it to do velocity or speed, you would have a velocity. You can also do velocity versus time, and it would, in fact, measure the velocity every 60th of a second. So it's pretty precise, right? This will be divided into teeny little increments, and then you could do this, right? And if you had a steady slope, that would mean the velocity or the speed would be constant. If a photo gate, right, is a gate, just like it says, and the cart has to pass through it, it'll find the speed at that position, right when it's there. So if you put a gate at the beginning and a gate just at the end, you'll know what the speed is at the beginning and at the end, but you won't know anything about what's going on in between. So this is a better way of measuring it than this one. So that's really what you want to say. You want to say Angela's, right, will measure all points from the beginning to the end. While Blake's only measure the beginning and the end. Now, of course, if we do Blake's way and the beginning and the end are different, well, then obviously you don't have constant speed, but you really only, this question is really asking about constant throughout the motion, which implies you have to do the middle. So hopefully that makes sense to you.